Hi guys, and welcome to this video. My name is Gan Emmanuel and I'm a software engineer, and today we are going to be improving one of our last videos where we talk about it's a simple network system that does client server using TCP connection and sending message. So we're going to be looking at protocol design and a few other things. However, though, this is not this is like part of me learning stuff. I have been doing system engineering, learning system engineering, basically trying to understand how communication work at the very lowest level, reading and writing from network and designing protocols and designing systems on top of that, so application systems on top of that. I built a simple chat application. I designed it with the help of AI. I'm using AI to learn, and these are kind of like my this different chapter. I have them, bunch of them. This is chapter one to chapter 11, chapter 10, chapter 3 to chapter 10, something like that. Um, so this is what we are going to try to redo. Again, I already did this, but again, continuous practice is very important to get it to understand. In the last video, we did something similar, and today I just want to, try it again. And this is going to be in terms of parts. And the first thing we're going to do is that we're going to create is going to be a mini chat system. And this is part of this is an official series at least this time around, which we're going to be building a kind of a WhatsApp architecture, a chat application progressively, and we're going to extend. We're going to build the core communication model today, and well, at least in the first couple of videos which you are going to see, and then we are going to iteratively improve that. We're going to add basically we're going to add types. We're going to add different handling based on the types, event driven and other stuff. So for now, we just want to create our chat application, right? Chat application, and as you can see, we are going to define the protocol. We're going to create the protocol for each of them, and I'm going to try my best. So just to make sure that, so I'm just going to have a connection because we're going to also define the attachment connection. I'm going to try my best to program what I can and then refer back to what I already did for other things. And well, we're going to write code, right? No copy and paste, no AI. It's what I kind of do. Eventually, when you're actually building system, you want to leverage AI to speed up the work. But now you're learning, you're understanding concepts. It's been amazing thus far, and I just want to do it. I did it the other day. We have about 2, 3 videos of them. You're going to see on the channel. This is another one, and I'm still doing it, and I will continue to do this again for about a month, and then being what we like, for example, tomorrow will mark the first. We are going to see, we're going to be building throughout that month, and we're going to see a lot of stuff regarding system building. We're going to take popular protocols and we're going to be building them. So this is just like an introductory video alongside programming itself. So today we are going to define. If you watch our last video, the protocol is basically an agreement between two, let me say, two entities in the system, right? So in this case, a client and a server. So it's an agreement of communication telling you how the communication is going to be handled and how you handle transmitted data within that particular network and within this particular system essentially. And that's what the protocol is. And today we are going to be modifying our previous implementation a little bit to handle packets rather than read-write context, right? So we're going to actually try to reference networking names, naming mechanisms, and realities. So the first thing we want to do is create our packet, right? We want to create our packet, and our packet here will contain is something really basic. Again, it's going to contain something called a timestamp, which is going to be a long. In this case, we're going to call a private long timestamp. Okay, and it's going to contain the message, but in the binary format, right? So we're going to create a byte array, which is now going to be the message or the payload. Let's say the payload. Okay, and that's what our packet is going to contain. But these are all private. These are private methods, right? And we want to have our constructor, which is going to be packet, and we want to take the long, and this is going to be a timestamp, and then we're going to have our byte array, and this is going to be our payload. Okay. And this will simply, of course, you already know how this goes. Again, this is Java, by the way. So if you don't know Java, then I'll advise you to. But the concepts are identical across the language, just that I'm using Java-specific syntax and programming, and some other things I say will be Java dependent. So take that into consideration. So this dot timestamp will be equals to timestamp, of course, and of course this dot payload equals to payload. There you go. And we're just going to get getters, and I'm just going to generate those, right? I'm using IntelliJ to generate the getters, so just going to generate the getters, and that's all of it. Okay. And that's pretty much our packet. And the packet is, if you study networking, then it just contains the information that your application sends, right? And then within the network, the packets, it can be things can be added, either the tail of the packet or the head of the packet, and this will reference different levels of your networking progress. In this case, you can look at the basic model like the OC model, a structural standard model like the OC model, and within from different sections, different layers, you move from a packet to a frame to different things, and those have things housing. So if I wanted to create maybe like a frame, I could house this packet. I could maybe create another class, say have a class, right? So it was a public class. This is just an example, just to explain to you packets. I could have like public class frame, and then within this class, I could have a private packet, and then have like a packet, right? And then within the packet itself, I want to have, say, private head or header, right? So private, whatever it is, the header could be, say, binary, say byte, okay. So the private header and or private head, okay. And then I could have a private byte tail. Okay. And then this now become the frame, and this we'll have the encoders and the decoders for each of these different data structures that we create, housing internal data structures within them, and based on the level, they are going to be encoded and decoded accordingly. And this is a kind of a similar idea we want to kind of initiate from the onset with the packet. And our packet in this case, we have basic information. Later on, we will extend it to include types, right? We can extend it to include other information here. Information from our app system. So from our application. So basically, these are the core information that you are sending. So when you have a packet, you now have something called an encoder and a decoder. Now, an encoder or encoding, an encoder performs the function of encoding your information, the packet, to the appropriate format, like to the protocol, the accepted format, the agreed upon contract that your network uses. And then the decoder decodes that information to back to the packet, allowing the other application to read the information from the network and know exactly what the other application sent or the other network node sent. And that's the idea. So we are going to create a packet encoder. Um, right. And an encoder, let's say, that name. So a packet encoder, what does a packet encoder do? It takes in the information and wraps it into the acceptable contract format. Okay, and in this acceptable contract format, our format is going to flow like this. We are going to have the the length, right? That's that, and then it's going to be followed by the header, and then it's going to be followed by the payload. Okay. Now this header, for the time being, is going to contain just the timestamp. Okay. And that will be what our encoder does. Our encoder is going to give us basically a byte array or something like that that sends information in that format. So when we send information, we want to encode information, we get the encoded information. We basically return an encoder. Okay, we can then have the encoder get information, right? Or do a lot of other things there. So the encoder will have what will the encoder take? The encoder will take the packet, right, and then perform an encoding function on it. And so we're going to have a public in the constructor, which is going to be packet encoder, right? And this is going to just take a packet, and this is going to be the packet. And then within the constructor, it is going to perform encoding task because you just want to pass it and it gets encoded, and then it performs the encoding task. But then where do you save the data that has been encoded? And so you could simply just have I want to put encoder.get. So this would be a byte string. Would it be a byte buffer? It depends on how you want to do it. You could have like a byte buffer. Again, you could have like a private byte buffer. Okay. Private byte buffer, and this would be the what do you want to say? The payload or the message. So encoder.get message. Okay. Or get data. They just say get data. Yeah, right. So it's basically data. Right. The data has different levels. So it has a header. Yeah. So all of it is data. And then within here we can now perform the encoding. And the packet, as you can see, contains timestamp, which is in the long format, and a byte array. And we just want to have that. And let me see. The encoder, you know what? The encoder, no, the encoder we're going to have three types of buffers, right? So we're going to have private, the header buffer, so the length buffer. I think smart will just have like a byte array that has like the length buffer because it all sends in the same array. But again, we want to follow so we're going to have byte buffer dot length buffer. Okay, and we're also going to have private byte array, and we're going to have header buffer. Okay, also going to have a private and with a byte array. Then this is going to be the payload. Again, this is just making it a little bit more clear. You could put all of it you want to be just data and then just get the data and stream it to the other end. But just for much clearer to maintain what we did the last time, so you're able to map it physically, we are going to do this, right? So we have the different buffers, and we're going to perform the encoding here. And what we're going to do, the first thing is that we want to get the packet, we want to get the payload, and we want to first of all we want to initialize all of this and attribute their buffer sizes based on the agreement of the protocol. And our packet is going to take, it has already two attributes there, which is the timestamp and the payload. Now, for the timestamp, in terms of length, the number of bytes it consumes in a particular array, it's a long, and so it's going to consume 8 bytes. Integers will consume 4 bytes, and so on. And the payload, we don't know the amount of bytes it's going to consume, so we can get it from this byte array. We can get it from the byte array, and so we want to say, first of all, want to calculate the length, want to do the length, and the length of the buffer essentially will be the length of the entire packet, or the entire encoded packet will be the length of the current length value itself, the length buffer, plus the length of the size of the current length buffer, plus the size of the header buffer, which is the timestamp, plus the size of the buffer payload, which will be the payload. And so the length buffer is basically going to be an int, and so we are just going to get an integer, right? So we're going to get, we're going to have like a int, we're going to have packet or encoded packet size, right, which is going to be so it's going to be 4 for the length of the payload, for the length of the buffer, for the length buffer size, or the size of the length buffer, yeah, that's correct, for the size of the length buffer, plus 8, which is the size of the header buffer, then plus, we're going to get payload buffer dot get dot remaining. Return the number of elements remaining in this buffer. I hope no, okay, no, this is payload buffer, sorry, it's packet. We are taking the packet, packet dot get payload dot length. Okay, that will give us our length of our packet size, and this will be our encoded packet size. And then we want to attribute these particular values. So we want to do, so I'll just add comments here, get length or get size of encoded data, right? So, and then here we want to initialize length buffer, right? And we're going to do length buffer dot length buffer is equals to byte buffer dot allocate, and we're going to allocate 4 there. Okay, and we're going to do length buffer dot put int, and we're going to get this value encoded packet size as an integer there, and then we are going to flip it. I'm preparing it for because right now we're writing into the buffer. We now have to prepare it for reading, and we're going to do length buffer dot flip. Okay, and then we are going to do initialize header buffer. Okay, and again, same thing, we're going to do header buffer equal to byte buffer dot allocate. We're going to allocate it there, Again, these are agreed upon. These are contracts, right, between the two within the system. So these are numbers that we've basically agreed on, so they don't change. And then we're going to do length buffer dot put in, put long, since long is 8, and we're going to put in the packet dot get timestamp within there. Okay, and we're going to do no, not length buffer, header buffer. Header buffer, and we're going to do header buffer dot flip, preparing it for reading. Oh, yeah, reading it and then writing it to the network. And we're going to do for the last one, which is initialize payload. Again, payload buffer is equals to, and this time around, we just want to we want to get a size of that particular payload, and in order to do that, we're going to get the payload packet size, and payload get the bytes of that particular payload. Let's see, encoded buffer. Oh yeah, okay, that's true. So this will be and what we'll do is that we are simply going to wrap the, the we're going to do the wrap, right? And it will what this is essentially going to be equivalent to allocating the size of the payload buffer to the length, and then putting the packet of that in there and then flipping it. So just putting the packet, then we have to manually flip it. And so we can just use the wrap method that's provided to us, and we're going to put packet dot payload. Okay, and then we're just going to do payload. Sorry, payload buffer dot flip and prepare it for reading. And just like that, we have all of our information, right? And again, these are not mutable, so we need to just generate the getters. Okay, and that's all, right? For the packet encoding, what we can do, you see, we can have an encoding because we could have some interesting methods within the encoding. It's just that there are, let me see. You know what, let me, so there are certain methods that are very nice to have. Like for example, we want to get current, and you see current buffer, so you get current buffer, and we also want to advance, and we also want to check finish. Okay, and these are kind of important because you would also oh you would need this when you are doing read-write operations. Write operations, not read-write operations. And in our decoder, we also do similar methods like this. And I forgot one thing here. We need a state, right? So we need to create a write state. Okay. And basically, the write state is going to tell us which buffer we are currently writing into, because TCP has some certain rules that require us to particularly handle read and write specifically for those cases, because with TCP you cannot guarantee, it doesn't guarantee that when you send a packet, everything in the bytes, all the bytes in that particular packet are sent at once. However, it does guarantee ordering. That's it. So you have to repetitively write a single buffer until all the bytes within that buffer are written to the network, and same thing for reading. And you need state to handle safely and make things easier to understand where you are at every given stage. And we're going to have two states. We're going to have the write state, since we're now dealing with the encoder, which basically write is used for writing, write state. Okay. And the write state will have, it's an enum. Okay. And we're just going to have a simple enum, which is going to be write. So write length. Okay. We're also going to have write header. As you can see, it's very simple. I'm going to have write payload. Okay. And the read state, I'll just go ahead and create the read state here. Which is the same thing. Read state. And the read state will have the read length. Oh, that is read length. And we're going to have the read header. And we're going to have the read payload. Right, so we do have those reads. So we have the write, we have the read, and right here we are going to have our private. So private, I would say write state, and we're going to have the write state. And also we'll just initialize our write state. Oh, sorry. Write state to be equals to write state of write length right here. So that will be our packet. Right. So whenever we initialize a packet, we'll do that. So I don't know if we have like a get state, get calling buffer based. It should be based on state. And I think the state itself. The state itself. The state itself will be they are final, so they can change. Yeah. So we'll have a current buffer. We'll have a public. So it's going to return a byte buffer, and it's going to do current buffer, and this is just going to return based on state. We're just going to use like a switch statement. I'm going to have state, write state, and this will have case. I don't know exactly why. Oh, so this returns, sorry. Yeah. Interesting. So, exactly. Alright, so we have case. If it is length, then we want to return. So if it's length, we just have length buffer. Right. It's case. If it is header, we want to have header buffer. And if it is case, and if it's payload, we want to have payload buffer. Right. And again, we are determining based on this case, right? The right state. that will be it. So current buffer will be based on that, and the ability to advance, right, to move to the next state will be public void. Yeah, public void, and the advance. So it will just basically based on the current state, it's going to do another switch, and we're just going to write state. And again, it's going to be case. If it is length and we want to advance, then we want to do write state equal to write state dot header, and the case, and if it is header, we want to do write state equals to write state dot payload. Okay. What if it is payload? Then we want to advance back. Yeah. So if it is case payload, well, then we go back to the length. So we want to do write state equals to write state dot length. So even at the end, we can just advance and come back. So that's what we have to do, and we can have this helper method here, and then check finish. Essentially, we are checking whether or not we have it somewhere here, and so the check finish public boolean is finish. Finished, and this is just so it uses the components within the object itself to check the finish, and we're going to have again this case is if state write state dot equals dot equal to write state, it is payload, and so if we're at the end of it, and so if we are at the end of it, and then this will find out. I guess what we can do here is reset state. Yeah, we could have a reset button. We have like a reset, but this is a write. We just discard, right? It's the read that will do the reset stuff, but essentially we want to do payload buffer dot has remaining. We want to make sure that it does not have remaining, which means we're completely written it all. So we just return that. That's all. So this is the computation to return it. So we're checking, return the case. If it does not have, if it's in the last state and it does not have remaining, then return true. That means we're done finishing. However, if anything else, then return false when we're finished. And that is it for our packet encoder. I would guess. Make for final. No, yes, we want to make proof of final. I mean, we're going to discard them. Right? We're not doing any computation, and we're also going to. Anyway, we'll see if, of course, this is supposed to be final or not. So we can always change it back. We don't have the getter and setters though. I mean, the getter has no setter, and we can advance based on it, which means that we don't necessarily ever need to get it to extract the current state, right? So it keeps everything tight and neat. So that will be our encoder, and we'll have our decoder. We'll have a class which is going to be a packet decoder. this way, obviously. And the decoder does that. It receives the, so it's going to take in, what will it take in? Packet encoder. I think it should take in a byte array. What should we take in? Because it's going to read it. No, I've done it. I'm trying to remember what it should take. Definitely, we are going to have our private fields. We're going to have the byte buffer. No, I think we do want to have the. So essentially, the decoder is it reads, right. Well, it reads. So I think it also work with the packet, and so it would take in the packet, and it would decode the byte stream, the byte array into an actual message. I would think. Okay. Um. So so it will decode the actual message into a byte array, because the encoder gets a packet, right, from the application, and then the decoder will extract it, and the node will pass the packet to the decoder, and the decoder is responsible for spitting out the actual information, like the actual text, and also maybe like a timestamp, whatever it is there. And the decoder will probably want to take the packet, and we'll take the either we'll take the packet or take the payload and the timestamp. The packet is sent in the payload and timestamp, and then what it might want to do is you might want to now compute the. It seems a little bit small, but that's how I'll go about it. By buffer dot the buffer itself doesn't have to. So the decoder will not be working with the buffers. I'm trying to see if we are going to work with the buffer. Then what are we going to use it for? Okay, so the decoder itself. So okay, the decoder. Let's break it down. The decoder reads information. So the decoder is supposed to. It works in the application layer that so on the server, it basically deals with information that has been read from the network, right? That's what the decoder does. So it basically transcribes it back to the actual readable text. And within the server the server itself, the server computation, let me say the event loop, we could have methods such in fact we are going to have methods such as being able to build packets. So when we read, we should be able to build a packet, right? And the decoder should be able to to be able to like decode this information. And yeah, okay. So it should be able to like decode this information and then print it out to the screen at the very least, right? So in a sense, we should have like a public um, packet decoder, and then we have like a packet. It takes in a packet, and it's going to be the packet, and then the packet now has the information within it. It has a timestamp, and it has the timestamp. It has the payload. so the decoder knows that, okay, maybe I just want to first of all print this out to the screen. So print, so basically print to screen payload, right? The payload. So we can do like system.out, and we can do new string, and then we can do packet.payload, and that's like a byte array, right? So that's going to basically print that out. So very generic stuff. Also, you could like do the time thing where you create like a zone ID, then the zone format and stuff like that. But I also think that the decoder will also perform. So for this particular case, we want to like respond back to the to back to the, what is it? Anyway, so right now I think I'm fuzzy up on what the decoder should do, at least for the architecture I'm trying to do. I think if I go on my own, I would definitely do something about it, perform, and it will work, but it will not be exactly what I want to do. And I'm trying to stay strict to it. And don't get me wrong, I would love to go on my own here, but there's a reason why I'm trying to stay strict to this. It's a learning, I have a learning plan that I have to follow. And right now, the ability that I'm thinking about this is good for me. But then I just need now to understand exactly in this particular architecture what the decoder does. And so in this case, the decoder just gets the length buffer and byte buffer, the header buffer, and the byte array and the packet length, the state. While the encoder in the previous one, it has obviously you will see that thing. You do have the packet which is correct, and as you see, we did this particular computation, and then we did the current buffer state stuff, as you can see, and we also did the advanced state and the finished state. So that is good. This is good. So the decoder, I think I was messing up here because I thought it would use about the same thing. So it's taking. Oh yeah. So this is like the right. Okay. So with respect to what we did last time, this is like the right, read context. And so it's just going to take the generics and define them all to the same place. So it doesn't really take any construction because I was trying to overcomplicate things, and I think it will be the connection that does it. Or okay, that will be done in the worker pool. I know I'm blabbing a lot, but so we're just going to define the so is it private? We could make it private and public, but then that will require settings and data. So we just make it public immediately, which I think that's what we did here. Yeah, so that's what we did there. And we're going to do, of course, the private is quite good. It allows for encapsulation and control access. But again, generic stuff here. I'm not just using it. So public byte buffer, and we're going to have length buffer, and that will be so byte buffer dot allocate again for, and public byte buffer header buffer. You get the idea, right? Header buffer, and that will be byte buffer dot allocate, and that will be it. And you know what? I'm just going to duplicate this here, and that will be payload buffer. Right, and then the payload buffer is not what was the word for it? It's not initialized because from the decoder standpoint, we have no idea the size of the payload. However, we can then compute the public length or packet of, let's say so this will be an integer, and this will be equal to -1. That's we initialize to -1 now. And then of course we're going to have a read public public read state, and we're going to always initialize read state to be equals to read state length to start with that. But I also do think that you see the method we have, the advanced method that we had here. So let's confirm that that's the same thing. We to find and stuff like that. The advanced methods that we had here, okay. So these methods, I think we can use them here. Okay. Because we're going to perform the same read-write operations. It's going to be the same loop, and as you're seeing in the previous video, as you will see, it's just much easier to, and even here it actually does make sense to have certain things like this, right? In this case, and we can just copy that and paste it there, and of course, and this will be read state, and so this will be read length, this will be read header, this will be read payload, okay? And obviously, and so what I'll do is I'll do this, rename read state, rename and so this will just be like read header. Um, so for the advanced, for the other one, I think we had the case here that we deleted, remember, and we have a payload they want to write. Yeah, we don't actually need it because after that we discard that. So, well, yeah, we do discard that. Yeah, once we write, we discard that, so we don't need that there. Because once we add the payloads, this particular object is no longer useful. We just discard it. However, here we need to reset it, and so that's why we're going to have read end. So read state read end. Read state read header. And I'm just going to have a case read state equals to read state read end. But here again, like I said, once we are at that end, we don't need to. What's happening here? Move it on that statement. Also with payload, so yeah, so and with header. So that's the case there. And just going to have read state here. So read state equals to read state dot read payload that has remaining. Once that doesn't have remaining, then we want to have a kind of a public method here, although that wasn't added here. I think this would also be good, which would be void reset. I don't know if I should put it like a boolean so I can check for it, or I should just put it void reset. I'll just do reset decoder. Right. And this essentially is going to put these values back to their state, as you can see. So this is going to have the length buffer dot here, and this is going to have the header buffer dot here. But so these stay the same. They have fixed amount of fixed size. However, the payload buffer will have a different size. So we don't clear it. We simply reallocate it to a null value. So we have payload buffer to be equal to null, and then we do have the length, the data size, data length should be equal to -1 back. Okay. So that should make things a little bit easier to work with in the future. So we have reset folder. Okay. So we do have this method that provided on both sides, and well, as you can see, well, each of them are providing the same method, which means that you could, in a sense, make this particular thing an interface, right? So we could have maybe we could have an interface called a protocol, and then all of them they implement the reset, or they implement all the method. But again, this particular one is not the same for all. But again, it depends on how you define your buffer, how you're going to use them. But for this case, this is fine. So we define the protocol, as you can see. So we do the network. As you see our network protocol, we go to our chat protocol. There's our chat protocol. So we have the packet. We have the packet encoder, the packet decoder, the state, the write state, same thing. So it is about the same. And right now we are happy. So I'm going to leave it there. For the next video, we are going to talk about the connection. Oh, you know what? I think that is easier. So yeah, I'll leave it for the next video. We're going to talk about the connection, connection context, where it's like a state for your channels, your connection. And I'm going to talk about it, and we're going to build it, and it's going to use decoders and encoders. And then we're going to build the core, which is this part. Then we're going to finish it with the different clients and servers. So this for now is the beginning, and this is looking really good. And we just needed to do 1 or 2 references, and this is fantastic. So that said, thank you for watching, and see you in the next video. Okay, subscribe to the channel also.